I am honored to have the chance to speak at the conference. The topic of this paper is a combined method for usage of NLP libraries towards analyzing software documents. I am the first author, Xinyun. Here is the outline. In Section 1, I will introduce the motivation. In Section 2, some background knowledge of our method will be discussed. The approach of the combined method will be introduced in Section 3. Then, I will introduce the experiments conducted in this paper. Finally, a simple conclusion is given. Let's move to the first part. As we all know, software documents are important sources of knowledge in an information system. For different purposes, the documents are commonly written in natural language by some developers or automatically created by generators. Many researchers apply state-of-the-art NLP libraries on analyzing these documents. The rich sources of candidates result in a new problem on the selection of suitable NLP library while analyzing software documents. In most cases, the selection of NLP library is subjective. However, the subjective selection may pose threats to validity. Omren and Chud propose an empirical study to give a guideline for choosing appropriate NLP libraries. However, this guideline cannot always help researchers to choose the best NLP libraries for a specific task. There are three reasons. First, there exists a great variety of software documents in real world, and it is too tedious to produce a universal guideline for all the types of software documents. Second, the NLP libraries are optimized continuously. The existing guideline may be inaccurate in some upcoming scenarios. Third, different types of software documents may be analyzed together in some cases. The individual selection of different NLP libraries on different documents and NLP tasks may weaken the automation. Therefore, we tend to investigate a method to use NLP libraries together. Our study has two main novel aspects and two contributions. First, we conduct an empirical study. We investigate the effectiveness of NLP libraries and prove that the existing guideline should be updated with the evolution of NLP libraries, and each library has its own exclusive results. Second, we propose the combined method. This method combines the strengths of different NLP libraries, and it can outperform any individual NLP library in the experiments. Let's move to Section 2. In this section, I will introduce some background knowledge of our method. Firstly, I want to introduce some NLP libraries briefly. There are a lot of NLP libraries in both academia and the industry, and the publicly available NLP libraries are very popular in the analysis of software documents. NLTK is a platform for building Python programs to work with human language data. CAiSE is another free open source library for NLP, which is called Industrial Strength Natural Language Processing in Python. Stanford Core NLP is a set of open source Java NLP tools developed by Stanford University. Google's SyntaxNet is a new open source natural language parsing model. Apache OpenNLP is a toolkit based on machine learning for processing natural language text. Secondly, NLP tasks denote the various purposes of analyzing software documents. Tokenization is the process of dividing a string into several parts. Stop words removal is the process that some words or phrases are filtered to save storage space and improve search efficiency. POS tagging is the process of determining the grammatical category of each word in a given sentence and tagging it. Thirdly, I want to introduce some software documents used in this paper. The documents of feature requests can be extracted from Jira. There is not a standard of the formalization of the language. README files are written by the developers to help other people understand the projects. Developers can author the files in different languages. Java API documentation contains many code elements, which may obey the rules of grammar in daily expression. It is the official text provided by the community. Section 3 is the approach of the combined method. The overall framework of our combined method is illustrated in this figure. The combined method mainly consists of two steps: document level selection of NLP library and sentence level overwriting. In the first step, we apply the chosen NLP libraries to produce 4 sets of results independently. Then we calculate the degree of overlap for each studied NLP library. The NLP library with highest degree of overlap is selected as primary library, and its outputs are transferred to the next step as primary outputs. Document level overlapping degree of an NLP library defined in our experiment is the average proportion of identical outputs among the results achieved by it and any other NLP libraries individually. The degree of overlap between NLP library I and J and the document level overlapping degree of library I are calculated as follows. The reason for choosing a primary library is that the studied NLP libraries are all widely used and well maintained by professional teams, so the expected effectiveness of these libraries is high enough to ensure that the identical overlapping results in their outputs are highly possible to be correct. The selected NLP library in this step is supposed to have the best overall effectiveness. Then, we try to investigate the fine-grained improvements on sentences. To locate the potential sentences, we calculate the overlapping degree of the primary NLP library for each sentence by treating it as an individual document. We mark several low overlap sentences. These sentences have less sentence level overlapping degree than the document level overlapping degree of the document they belong to. The outputs of primary library on low overlap sentences are highly possible to have great space for improvement. For the low overlap sentences, we overwrite its primary outputs with another set of results from the library which has highest overlapping degree on it. Let's move to next part. Our experiments investigate the following 2 questions. Question 1. Does the existing guideline for NLP library selection still work for the latest version of NLP libraries? Question 2. How effective is the combined method compared with individual NLP libraries? To answer these questions, we conduct experiments with 4 NLP libraries and several documents from 3 different sources. The NLP libraries we selected are NLTK, CAiSE, OpenNLP, and Stanford Core NLP. The selected software documents are shown in this table. The total number of tokens from the selected software documents is around 40,000. We select 2 NLP tasks in our experiments: tokenization and POS tagging. The experimental steps are as follows. Step 1. To control the size of inputs from different sources, the selected 200 documents are repartitioned into 100 new documents. There are about 400 tokens in each document. All the documents are used to analyze the overlapping degree of the study techniques and help to evaluate the existing guideline on NLP library selection. Step 2. The 4 NLP libraries are applied to analyze the pre-processed documents for tokenization and POS tagging. Step 3. To obtain the benchmark, 20 students in our group conduct manual tokenization and POS tagging. Due to the limitation of human labor, we only collect 50 documents to build the benchmark. We also perform a cross-validation to identify the controversial spots. The final results are determined through our discussion. Step 4. We apply the combined method on the collected 50 documents and discuss the effectiveness of our method and the 4 NLP libraries based on the handmade benchmark generated in Step 3. For the first question, we compare the generated results with manual annotations. Table 1 and 2 show the results of comparison on tokenization and POS tagging respectively. From the data in these tables, we know that Stanford Core NLP and NLTK perform best in terms of accuracy of tokenization on software documents. However, in the existing work, NLTK is the best one. Furthermore, OpenNLP is the most effective NLP library on POS tagging in our experiments. However, in the existing work, SPACE outperforms other NLP libraries on POS tagging except on README files. Therefore, the first finding is that the guideline of NLP library selection should be updated with the change of releases and given documents. For question 2, Table 3 represents the data of overlapping degree. Comparing the results in Table 2 and 3, we find that the accuracy of POS tagging is higher than the overlapping degree of the paired NLP libraries. In most cases, it indicates that every library has its own exclusive correctness on POS tagging. This finding inspires us to combine the exclusive correctness of each library to achieve an improved effectiveness. We apply the combined method to generate results. The final results on tokenization and POS tagging are shown in last 2 rows in Table 1 and 2. We can see here and here. The results show that the combined method outperforms the studied libraries in most cases, and the promotion is about 2%. Since the initial results of the NLP libraries already have high quality, the 2% promotion is small but meaningful. Therefore, the second finding is that the combined method can generally outperform the individual NLP libraries in terms of effectiveness, and the promotion on accuracy is about 2%. In our experiments, 1% of correct tokens and 4% of correct POS tags come from the improvements in sentence level overwriting, and the other correct results are generated by the primary NLP library in document level selection. Therefore, the last finding is that the majority of correct NLP results come from the outputs of primary NLP library, and the meaningful improvements of our combined method on individual NLP library come from sentence level overwriting. The last section is a simple conclusion. This paper evaluates the existing guideline on NLP library selection with 4 NLP libraries and 200 documents. The results report that the guideline should be updated continuously, and each library has its own exclusive results. Based on these findings, we tend to investigate a combined method to utilize the strengths of different NLP libraries. The evaluation confirms that our combined method can outperform any individual NLP library in the experiments. In future, we will conduct the study on more NLP tasks and with additional NLP libraries and different software documents to improve the combined method. That's all. Thank you for listening.